modern lightweight diesel engine has become an accepted part of the motoring scene. It's efficient and economical, particularly around town. The image of slow, smelly and noisy diesels associated with the older and poorly maintained commercial vehicles has all but disappeared. High revving and quieter running diesels are now an established part of the passenger car market. Environmentally, the diesel has also become more acceptable, as a correctly maintained diesel engine can produce less carbon monoxide and less unburnt hydrocarbons than a catalyst-equipped petrol engine. Recent developments by Volkswagen have seen the introduction of an even cleaner diesel engine, known as the Umweltdiesel. Umwelt is the German word for environment, and this new engine has been specifically designed to produce lower exhaust emissions. To ensure reliable and quick cold starting, a glow plug is fitted to each swirl chamber. Once the dash warning light has gone out, the engine can be started. The period of time during which the plugs and warning light are lit is dependent on the coolant temperature. On some more recent models, a more sophisticated system known as extended glow period is fitted. It comprises an electronic control unit and a relay with a combined resistor pack and fusible link. In this system, the glow plugs remain lit at a slightly reduced voltage for an extended period of time after the initial startup. This helps to further reduce noise, exhaust emissions, and improve the idle. Fuel is drawn from the tank via the main filter assembly by a self-bleeding vane-type lift pump, which is an integral component of the rotary injector pump. A drain tap, on the bottom of the filter, is provided to drain off periodically any water that may collect in the system. From the internal lift pump, the fuel enters the high-pressure element of the injector pump. Simplified, here the fuel is both distributed in the firing order to each of the injector outlets and pressurized to a very high pressure. This high pressure, which builds up in each injector pipe in turn, is determined by a spring within the injector. The spring holds down the injector needle, keeping it firmly on its tapered seat. Once the spring pressure is overcome by the fuel pressure acting on the needle lifts and chatters. Due to this action and the design of the needle and nozzle assembly, a fine cone-shaped atomized spray is produced. This is essential for good ignition. The quantity of fuel sprayed, or more correctly injected, is determined by both the position of the throttle lever and the governor mechanism within the injector pump. When the injector needle closes, any excess fuel is returned via the return lines back to the tank. It also joins fuel returning from the injector pump. On later vehicles, this return line fuel, which has been warmed by passing through the injector pump and system, is recirculated through the filter assembly. This helps to prevent the fuel waxing in freezing weather conditions. A thermo valve switches off this short-circuit recirculation through the filter when the fuel temperature rises above a predetermined figure. When the ignition is switched off, an electromagnetic cut-off valve, mounted on the injector pump, interrupts the fuel supply, thereby stopping the engine. For the purpose of this program, we use two 1.6-litre engines, one fitted to a Volkswagen Jetta and one from a Passat vehicle. However, the basic procedures demonstrated are similar for all diesel engines up to 1.9 litres. As diesel fuel can cause skin problems, for your own health and safety, make sure you always wear protective gloves or use a barrier cream before starting work. For the engine to work efficiently, it's essential that there are no air leaks within the fuel system. If an air leak is suspected, then the system can be checked quite simply by using the cooling system tester and adapters. Remove the return line from the injector pump and connect the tester. By the way, be careful never to exchange accidentally the return line union with that of the supply, as the return union has only a very small restriction drilling. Using a clamp, close off the fuel supply line near the tank and build up a pressure of about 1 bar. The injector pump and supply line are now pressurized and can be checked for leaks. You may have to pump up the system several times at first to expel any air. If the pressure continuously drops, then systematically reposition the clamp along the supply line until the leak area is localized. One particular area to check for leaks on later models is the rubber O-ring on the thermo valve of the fuel filter assembly. Incidentally, the fuel return line can be checked in a similar way by connecting the tester to the fuel supply connection. And remember, when working on the fuel system, absolute cleanliness is essential, as any dirt entering the system can damage the components. So before removing the injectors, start by cleaning the pipes. To avoid stressing the pipes, always remove them as an assembly and never individually. And to prevent fuel from being pumped out over the engine while cranking it, disconnect the fuel cut-off valve. Remove all the injectors and also the heat shields. This avoids the possibility of the heat shields being blown out into your face while the engine is turning over. However, to ensure a good seal when fitting the compression gauge, always fit a heat shield between the compression tester adapter and the cylinder head. Using the appropriate gauge, check the compressions in the normal way and compare them with the values in the repair manual. If a low compression is recorded, then it's advisable to carry out a cylinder leakage test to localize the fault area. While the injectors are out, it's also a good opportunity to check the operation of the glow plugs. Firstly, remove the wire from the temperature sender. This makes sure the glow plug system will operate irrespective of the coolant temperature. Switch on the ignition for a maximum of 15 seconds and check the glow plugs. If only one glow plug fails to light, then it will probably just be a case of replacing the individual plug. But if none of the glow plugs are working, then a thorough check of the wiring, fusible link and relay will need to be made in conjunction with the current flow diagram. If you notice a glow plug with a burnt end, then it's almost certain that the accompanying injector is faulty, and it will need to be tested. If the injector is not repaired, then serious and expensive damage to the piston and combustion chamber can occur. By the way, the heat shields, which protect the end of the injector and form a gas-tight seal between the injector and cylinder head, are compressible. So when refitting the injectors, always fit new shields and make sure they're installed in the correct direction. The first signs of injector problems can usually be recognized by misfiring, engine knocking, loss of power, exhaust smoke, or increased fuel consumption. Initially, a faulty injector can often be located by running the engine at a fast idle speed and slackening each injector pipe union in turn. If the engine speed remains constant, or the smoke or knocking disappears, then it's probably that particular injector which is at fault. While it is possible to adjust the injector pressure by changing shims, it may be more cost-effective if you're in any doubt about its overall condition to install an exchange unit. To improve visibility, we're working on a Passat engine mounted on an engine stand. The toothed belt which drives the camshaft, fuel pump, oil pump and brake vacuum pump should be free of cracks, oil and visible damage. By the way, if the belt is to be reused, make sure its direction of rotation is marked before it's removed. This enables you to refit it in the same direction, so avoiding excessive belt noise and wear. Set the crankshaft to TDC on number 1 cylinder. If the engine is out of the vehicle, as it is in our example, a special tool is required to determine the TDC position. The reference point for setting the gauge is the mark on the left of the vernier scale. Set the gauge to the value quoted in the repair manual for the particular engine and fit the tool. Recheck the setting and turn the crankshaft to align the TDC mark. Note that the TDC mark on some of the transporter engines is located on the clutch assembly. Next, fit the setting bar into the rear of the camshaft. To ensure the camshaft is set exactly, turn the camshaft until one end of the setting bar touches the cylinder head and measure the clearance. Halve the value and insert a feeler blade of that thickness between the bar and cylinder head. Turn the camshaft back slightly until the bar rests on the feeler blade, and insert a second feeler of the same thickness at the opposite end of the bar. Next, slacken the camshaft gear bolt and loosen the gear from its taper by striking it with a hammer and punch. Incidentally, the gear is secured to the shaft only by a taper. There isn't a key. This enables the gear to rotate on the shaft when tensioning the belt to achieve exact valve timing. Slacken the tensioner and remove the belt. As the Bosch type of injector pump is the most commonly fitted, we will demonstrate the procedures using this particular pump. Before fitting the belt, align the injector pump gear by positioning the notch uppermost and inserting this locking pin. And recheck that the crankshaft is set to TDC. Fit the belt and remove the pin from the injector pump gear. Tighten the belt by turning the tensioner clockwise until the correct value is recorded on the VW210. And make sure the crankshaft does not move while tensioning the belt. As you probably remember, the VW210 scale is read in a similar way to a micrometer. Tighten the camshaft gear bolt and remove the setting bar. To settle the belt, turn the crankshaft 2 revolutions and strike the belt with a rubber hammer. Recheck and, if necessary, readjust the tension. After adjusting the belt, it's important that the point of injection, or injection timing as it's more often known, is checked. To avoid incorrect readings being recorded, make sure the cold start lever is pushed fully in. Set the engine to TDC on number 1 cylinder and remove the plug from the rear of the injector pump. By the way, always fit a new copper washer before refitting the plug. Install the 2066 adapter, extension pin and dial gauge. Preload the gauge to about 2.5 millimeters. Turn the crankshaft slowly anti- or counterclockwise until the dial gauge needle stops moving. Reset the gauge to a 1 millimeter preload and zero the dial. Now slowly turn the crankshaft clockwise until the TDC marks are once again aligned. At this point, the dial gauge reading should correspond to the value specified in the literature. Note that 2 values are quoted. The test value is the tolerance that is allowed when checking the injection timing, while the setting value is the figure to which it should be set if it requires adjustment. If the timing requires adjustment, first slacken the injector pipes and the pump mounting bolts. Rotate the pump until the correct dial gauge reading is recorded and retighten the bolts and pipes. By the way, providing there is sufficient room, this special tool makes it considerably easier to move the pump. As accurate timing is essential, rotate the engine 2 further complete turns and recheck the timing once again. On completion, don't forget to check and, if necessary, adjust the idle and maximum engine speeds, details of which you will find later in the program. Finally, this screw, known as the residual volume screw, is set at the factory and should not be tampered with. If, despite this, the screw has been moved, it can cause flat spots, poor performance, or an excessively high idle speed. If you suspect that the screw may have been moved, consult the manual. So, we hope that by now you're a little more familiar with the various techniques and repair procedures that are required when working on the Volkswagen Audi range of indirect injection diesel engines.